Hey guys, welcome to R2E, and it's me Ramanuj Raman, and today in this video we are going to solve the problem which is on the interference of the sound waves, right? So first of all, let's read the problem and draw an appropriate diagram, because diagrams are always very much essential for solving the problems, right? So let's get started. So what it says that if I have two identical coherent sources, what does this mean? This word coherent means wait, let me change the color. So this word coherent means is that the phase difference between the two sources is constant, right? So and the two sources have both of them have the frequency f, and they are kept 5 meters apart, and an observer is standing. So I forgot to make a diagram again. So I have two sources R and S, right? And they both are emitting sound waves like this, and they are 5 meters apart, yes, again, and an observer is equidistant from the source. So both of these sources, so you have an observer equidistance, that is, say, some point O observer, and both this OR is actually equal to SOS, right? This is given, and the perpendicular distance of 12 meter from line RS. So if I join these 2 points like this, I'm messing up my diagram. Let's go about it. So the distance from the RS line and the O, it is of 12 meters, and here's the maximum sound intensity. So at point O, the observer is hearing the maximum sound intensity, which means that there is constructive interference happening at this point, right? For those who don't know what is constructive or destructive interference, they can consult their textbooks, because right now I can't explain it what is constructive and the destructive interference in this video. So please go and check out some other video from other YouTube channel to understand what is constructive and destructive interference. So but just for sake, I could only say that at point O, the constructive interference is happening, right? And what it says that as O moves parallel to RS in front of any of the any of the two observer, like either it goes to O dash, let's say its position is O dash, which is in front of the R, or O double dash, which is in front of the S, there is a minima, right? So at position O, the interference happens in such a way that there is a destructive interference, the superpositioning happen in such a way that at point O there is a minima, and again at O double prime there is again a minima of intensity of the sound intensity. So what I want to know is what's the possible frequency of the both the sound sources. So let's make a diagram for we already have a diagram, but let's use it now. Let's make it a bit better, and here it is. Let me join it. So yes, it's going to be perpendicular, and let's draw it a bit in, and so here it is O dash, it's R, it's S, it's 5 meter, and it's 12 meter. So for the destructive interference to happen at O dash, O dash S minus of R O dash must be equals to 2n plus 1 lambda by 2. This is a result from the Young's double slit experiment, right? And I'm going to directly use this result, and after that let's just solve it a bit. Let's calculate OS from the diagram. So OS is going to be, I'm going to use Pythagoras theorem, is going to be the under root of 12 square plus 5 squared, which is eventually going to be equal to 13 meters. So O dash S minus of R O dash is going to be 13 meters minus of 12 meters, that is equals to 1 meter, right? So 1 meter is going to be 2n plus 1 lambda by 2. Now here the trouble is that I don't know the wavelength of the, so I don't know the wavelength of the sound wave. What I know is the frequency. What I need to find out is the frequency, and what I know is the velocity of the sound wave, right? So, and we know the relation that v equals to lambda f. So I'm going to replace lambda by v and f. So lambda, which implies that lambda is equals to v upon f. So I'm going to replace it there, and 1 meter is going to be equal to 2n plus 1 v upon f, and which implies that f is equals to, oh wait, I missed something. Yes, I missed 2. Yes, 2n plus 1 v by 2. Now what it says is that what I need to find out is actually the frequency, right? So now let's try a hit and trial method, because here we need an option, we need my answer to match with these 4 A, B, C, D options. So let's start off with n equals to 0. Let's start off with n equals to 0 and v equals to 330 meter per second, and which will come out to be 330 meter per second divided by 2, which is going to be 165 hertz. And there's not an answer here, and here is no such answer here. So let's try another value. Let's try n equals to 1. So f is going to be 2 plus 1, 330 divided by 2. It's going to be 3 into 165, which is going to be 495 hertz. And yes, here is the answer, option number A. So my option number A, 495 hertz, is the correct answer. So thank you for watching the video, and I hope you liked it. For more such videos, stay tuned and stay subscribed. Thank you.